No, Q title card. Q title. What am I okay.
Behold gravity in all its glory!
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Roll the clips. Roll the clips. Hello, viewer. Today we're going to be talking about gravity, gravitational potential energy, and black holes. To start this off, we will be discussing the gravitational field. This is caused by the density and mass of Earth. It attracts all objects towards its center within a giant field around it. Because of this, every object on Earth is affected by gravitational potential energy. This energy is constantly pulling us towards Earth, and it is commonly referred to as gravity. Because of this, objects fall from the sky, they stay on the ground so they don't float away. Since this force is pulling us downwards, the only thing keeping us from flying through the Earth is the ground which we stand on. It enacts a normal force on us, which repels us from the center of the Earth, keeps us on the ground. Another example of gravitational energy within our solar system is the Sun and all the planets orbiting it. The Sun is the largest astral body within the solar system, and by nature has the most gravitational potential energy out of all of them. To be able to understand gravity better, scientists are looking at ripples in space-time that are caused by black holes. It is important to note that the Earth is not the only object in the universe, the galaxy, or the solar system even, that provides gravitational potential energy onto objects around it. Is the moon. The moon's a large enough body within the solar system that it affects the tides on the Earth. That's the moon up there. As the moon orbits around the Earth, the energy that it produces pulls back and forth on the tides. This causes high and low tides in the morning and afternoon throughout the day, and in general just increases the strength and height of the tides throughout the day. In 2011, an experiment showed that the Earth tugs on the universe like a wooden ball spinning molasses. This proves that anything with mass warps to space-time. The coolest thing about gravity is space, and an important part of this is the equation for measuring gravitational potential energy across two astral bodies. This equation is the force of the gravity equals the gravitational constant times the masses of both objects divided by the distance squared. Another cool aspect about gravity is black holes. A black hole is an object where the gravitational force is so big that not even subatomic particles and radio waves such as light can escape from it. Man, don't you just love gravity? Isn't it sick?
Physics lesson. Don't fall down.
Another great example of gravity taking place within our solar system is all the planets orbiting around the Sun. The Sun, being the largest astral body within our solar system, generates the most gravitational potential energy all the other astral bodies. Due to this, the planets, after being thrown off of their course by the Big Bang, started to orbit the Sun as it was the closest and largest object to them. This gave the objects circular rotations around the Sun, giving it an orbit, which allowed it to develop the ecosystems, or lack thereof, that they have today. A person who weighed 150 pounds on Earth would weigh less than 10 pounds on Pluto. How is this possible? I thought gravity was a constant. That's not necessarily true. Since Earth is a bigly planet, it exerts a bigly force. Pluto, on the other hand, exerts a much smaller force due to its mass, this causing someone of the same mass on the two different planets to weigh two completely different things.
Mr. Nee, are you aware that 62 miles above the Earth's surface, the pull of the Earth's gravity is only 3% less than it is on the surface?
How is this possible?
Are you also then not aware that in the International Space Station, astronauts aren't immune to gravity as some believe? They're floating due to centrifugal force. The space station is moving sideways at such a rate as to pull the astronauts away from the Earth, where gravity is simultaneously pulling them back down, thus giving the illusion that they are in 0G, allowing them to float.
Sick?
It is pretty sick, isn't it?
God. The coolest part about gravity is space. The gravitational constant is the... Stop.
Pretty lame, Millhouse.